Welcome to Bedtime Science. Tonight, something strange waits inside the stone of the world's tallest mountain. If you climbed all the way to the summit of Everest, you could chip a small piece of gray limestone. Inside, you might find the curled shell of a sea creature. It's older than the mountain itself. Much older. It once drifted through warm, shallow water. Tonight, we slowly look at the Himalayas. We look at the place where the floor of an ancient ocean became the roof of the world. In the quiet hours ahead, we'll visit how an entire ocean rose into mountains, how marine fossils came to rest near the summit of Everest, how glaciers sing in the cold darkness, how monks built sanctuaries above the clouds, and how snow leopards move like gray ghosts across the high stone. Before we begin, if you find comfort in these slow stories, you might consider subscribing. It helps our quiet community grow. And if you're still awake, you can leave a soft note about which hidden place we should visit next. Now let's begin. The story of the Himalayas starts underwater. About 225 million years ago, the landmass we now call India was not yet attached to Asia. It was a vast island, a drifting continent of its own. It floated through a warm prehistoric ocean somewhere south of where it sits today. That ocean had a name, the Tethys Sea. It covered the space that today holds Central Asia. The water was warm and shallow. Light reached the bottom in many places. Life filled it. Coral grew along the floor. Trilobites crawled through the sediment. Crinoids waved their feathered arms in slow currents, like underwater flowers anchored to stone. Cephalopods drifted through the blue, hunting smaller creatures with quiet patience. For hundreds of millions of years, this sea remained. It was a patient world. No glaciers existed there. No prayer flags above the clouds. Only the warm water, the soft sediment, and the rhythm of marine life on a sunken plain. Then very slowly, something started to move. About 80 million years ago, the Indian plate began drifting north. It moved at roughly 9 meters per century. That's about the speed at which your fingernails grow. But continents have patience. Over millions of years, even a slow drift covers immense distance. India crossed thousands of kilometers of open water. The Tethys Sea, ahead of it, began to close. Between 40 and 50 million years ago, the Indian plate finally reached Asia. They collided. Neither plate could sink beneath the other. Both were made of continental crust, light, buoyant, unwilling to be pushed down into the mantle below, so the pressure had to go somewhere else. It went up. The seafloor of the Tethys, caught in the crush, began to fold and thicken. Layer pressed against layer. Ancient sediment rose into the sky. What had been a quiet ocean floor became, very gradually, the steep stone bones of a new mountain range. The collision didn't finish. It still hasn't finished. The Indian plate continues to push north today at about 67 millimeters each year. Roughly 20 of those millimeters are absorbed by the southern front of the Himalayas. The range itself rises by about 5 millimeters every year. That's slow, but across a million years, 5 millimeters becomes 5 kilometers. Across 50 million years, the Tethys seafloor reached a height of nearly 9 kilometers above sea level. This is how Mount Everest was born. Now here's the strange part. The rocks at the summit of Everest still remember the ocean. Near the top, just below the snow, there is a band of gray limestone. Geologists call it the Kamalangma limestone. It is layered, ridged, and quietly ancient. If you split it open, you see compressed sediment, the kind that only forms on the floor of warm tropical seas. Inside that limestone, locked into the stone, are fossils. Marine fossils, shells of creatures that swam through water hundreds of millions of years ago. Crinoids, trilobites, brachiopods, ancient corals, tiny tooth-like remnants called conodonts. They were ocean dwellers, all of them. None could survive above water. None could live in cold. Yet here they are, near the summit of the highest mountain on Earth at over 8,000 meters. How old are these fossils? According to Dr. Solomon Buckman of the University of Wollongong, the fossils near Everest are Ordovician in age, about 420 million years old. They formed under the ocean on what was then the northern edge of India, when that landmass was still attached to Western Australia. Read that again slowly. 420 million years ago, the shells formed underwater. The Indian plate was still in the southern hemisphere. The Himalayas didn't exist. Dinosaurs hadn't appeared yet. The fossils are far older than the mountain that now holds them. NASA noted that the presence of marine fossils on Himalayan summits was one of the central pieces of evidence used to establish the theory of plate tectonics. When scientists first proposed that continents moved across the surface of the Earth, the fossils were proof. The seafloor in the sky was the fingerprint of motion. There's an Indian geologist named Dr. Ritesh Arya who once found a fossilized palm leaf on a high Himalayan slope, about 20 million years old. He described the moment in his own words. Suddenly, my eyes fixed upon something. I realized I found a huge, fossilized palm leaf. No record existed at that point of discovering such a significant fossil. I praised the Almighty, feeling lucky and happy, and immediately regained all my lost energy. A palm leaf, on a cold, high mountain slope, a leaf from a tropical coastal forest, proof that the place was once warm, low, green, and very near the sea. Let's look at the shape of the range itself. The Himalayas span about 2,900 kilometers from west to east. That's roughly the distance from London to Moscow. They curve in a long arc across Central Asia, between the Indian subcontinent below and the Tibetan plateau above. For all their fame, they cover less than 0.5% of Earth's surface, just 612,000 square kilometers or so, a thin strip on the map. But within that thin strip, the planet rises higher than anywhere else. The range holds 10 of the world's 14 peaks above 8,000 meters. Everest itself stands at 8,848 meters. More than 50 peaks rise above 7,000 meters. Nepal alone has roughly 250 peaks above 6,000 meters. The word Himalaya comes from Sanskrit. Hima means snow. Alaya means abode or home, the abode of snow. The range isn't a single wall. It's a sequence of parallel ridges stacked back to back. The outer Himalayas, the lower Himalayas, the Great Himalayan Range, the Tethyan Himalayas at the highest backside. Each parallel ridge rises higher than the one in front of it. From orbit, the Himalayas appear as a white arc cutting across the planet. They're one of the few geological features on Earth large enough to be obvious from space without aid. These mountains gather snow. The snow gathers into ice. The ice melts into rivers. The rivers shape life across an enormous portion of the planet. The Himalayas feed roughly 19 major rivers. The Ganges starts at the Gangotri Glacier in Uttarakhand. The Brahmaputra begins at the Yangtze Glacier in Tibet. The Indus rises near Lake Manasaravar on the Tibetan Plateau. The Yangtze, the Mekong, the Irrawaddy, the Yellow River, all of them somewhere trace back to ice fields high in the snow. These rivers are older than the mountains themselves. They were already flowing into the Tethys Sea before the Himalayas existed. As the land rose around them, the rivers cut down through the rising stone, carving deep gorges that exist nowhere else on Earth. About 1.9 billion people depend on water from Himalayan glaciers. That's nearly 1 in 4 humans alive today. Roughly 129 million farmers irrigate their crops with that meltwater. The water began as snowflakes on a ridge they will likely never visit. Far to the south, in the heat of Bangladesh, a farmer watches water move into a rice paddy. Months ago, that water was snow on a Himalayan peak. The mountains are far away. The connection is invisible, but the connection is real. Let's rise into the air around the mountains. At sea level, the atmosphere presses against your skin with a pressure of about 760 millimeters of mercury. The partial pressure of oxygen is roughly 159 millimeters. Your blood is well saturated. Your body doesn't notice. At 3,500 meters, the air is thinner. Oxygen pressure drops to 104 millimeters. Total pressure drops to 495 millimeters. The body starts to notice. Breaths come a little faster. The heart works a little harder. At 4,900 meters, only halfway up Everest's full height, oxygen concentration is half of what it is at sea level. Each breath delivers about the same volume of air, but the air contains half the oxygen molecules. The high air is also fierce. Winds at Everest's summit can reach 285 kilometers per hour. Winter summit temperatures average around -36 degrees Celsius. The jet stream itself sometimes grazes the upper ridges. Stratospheric air leaks down into the troposphere, causing rapid, dangerous weather changes. The monsoon does most of the work for water. From the south, warm, moist air rolls in from the Bay of Bengal. It rises against the south face of the mountains and drops its water as rain. About 15 feet of rainfall lands on the southern slopes each summer. On the northern side, in Tibet's rain shadow, barely 1 foot of rain falls in a year. It's the same range, but the two sides live in entirely different climates. Inside these mountains, more than 15,000 glaciers slowly flow. The Himalayas hold the third largest reserve of ice on Earth after Antarctica and the Arctic. Glaciers are slow rivers of ice. They move under their own weight. Most flow at speeds measured in centimeters or meters per day. You wouldn't see motion if you watched, but the motion is real. The Drang Drung Glacier in the Zanskar Valley runs for more than 23 kilometers. The ice within it is layered by time. The surface might be 10 years old. The ice near the bottom can be 10,000 years old. Inside a deep crevasse, the ice is blue. Not white, blue. An intense, improbable blue. The compression of crystals over centuries absorbs red wavelengths of light and reflects only blue back to your eyes. You can stand inside a glacier and look at the color of compressed snowfalls from 1,000 winters ago. Ice cores from these glaciers contain the past in physical form. Trapped inside each layer of ancient ice are tiny bubbles of air. Each bubble is a small sample of the atmosphere as it was when the snow fell. Glaciologists pull cores from deep within Himalayan ice and read centuries of climate, like pages from a slow book. One ice core from the Dasuapu Glacier, drilled in 1997 at 7,000 meters, held a record stretching back more than 2,000 years. The Glacier ice cap on the western Tibetan Plateau goes back further still. The mountains rise about 5 millimeters each year. They also erode about 1 millimeter each year. The net gain is roughly 4 millimeters. Over 1,000,000 years, that's 4 kilometers. The Himalayas have been doing this slow arithmetic for 50 million years. Modern ice loss has begun to accelerate. A 2019 study found that ice loss rates roughly doubled between two periods, the years 1975 to 2000 and the years 2000 to 2016. The pattern is consistent across the entire 2,000-kilometer span of the range. At night on the surface of a Himalayan glacier, the ice begins to speak. After sunset, temperatures can drop by dozens of degrees. The exposed ice contracts, fractures form, and those fractures release sound. The sounds range from deep booming notes to high cracks like glass under stress. Scientists camping on glacier surfaces have lain awake at night listening to the ice. Cryoseismologists place seismometers on the ice to record the vibrations. Each glacier has its own acoustic signature, shaped by its size, its age, its temperature, and the stone beneath it. There are also frozen lakes high in the range that produce strange sounds when their surfaces crack. The cracks release energy as vibrations at many different frequencies. High-frequency waves travel faster through the ice. They arrive at the ear first. The lower frequencies follow a moment later. The result sounds like a descending tone, traveling across the frozen surface. Above the glaciers, the sky has its own tricks. Pilots flying over the Himalayas sometimes see three suns. The real sun is flanked by two bright spectral images on either side. These are called sundogs, or parhelia. They form when hexagonal plate-shaped ice crystals in high cirrostratus clouds are perfectly horizontal. The crystals bend sunlight by exactly 22 degrees on each side, producing the two ghostly companions. The cold, the altitude, and the seasonal moisture from the monsoon make the Himalayas one of the most favorable places on Earth for sundogs to form. In strong temperature inversions, the atmosphere produces another illusion. Distant peaks can appear to float above the horizon, doubled, with an inverted ghost mountain hovering above the real one. This is called a Fata Morgana mirage. It's caused by light bending through layers of air with very different densities. And then there are cloud inversions. Cold valley air gets capped by warmer air above. Mist and fog gather in the lowlands. The peaks emerge clear, far above the cloud line. From a ridge at that hour, the ordinary world below has disappeared. In its place is a white sea with mountain islands rising out of it. These inversions can hold for days at a time. Above 4,000 meters, the sky itself begins to change. The atmosphere has thinned enough that its filtering effect on starlight grows weaker. The night sky darkens to a deeper black. Stars that are invisible at lower altitude become easy to see here. The Milky Way stops being a smear of light. It becomes a structure, a river, detailed enough that you can trace the shape of dust lanes within it. Near the horizon, stars no longer twinkle as much. The familiar trembling of starlight is caused by atmospheric turbulence. Thinner air means less turbulence, so the stars become steady points instead of shivering pinpricks. At a place called Hanal in the Ladakh region of India, an observatory sits at 5,290 meters. The Bortle scale measures sky darkness from 1 to 9. Hanel rates as Bortle Class 1, the darkest possible. The site averages about 270 clear nights each year. In 2022, the Indian government established the Hanel Sky Reserve. It covers 1,074 square kilometers of high mountain country, set aside to protect natural darkness. From inside that reserve, the night sky resembles what most of our ancestors would have seen before electric light covered the world. Moonlight, too, behaves differently up there. The thin air scatters less of it. Shadows on the ice and stone become sharper. A full moon over a glacier can be bright enough to read by. In the middle of this country of stone and ice, people have built places of stillness. For at least 2,000 years, humans have raised monasteries in the Himalayan heights, not for survival, not for trade, for something quieter. The mountains seem to offer a kind of nearness to silence, to sky, to whatever lay beyond ordinary life. Tibetan Buddhists call their monasteries gampas. Most sit at elevations between 3,000 and 5,000 meters. Many can only be reached for part of the year, when the high passes are open. One mountain above all others is held sacred. Mount Kailash in western Tibet rises to 6,638 meters. It is sacred to four traditions at once: to Hindus, Buddhists, Jains, and the older Bon religion. Each tradition came to it independently. Each agreed that its summit should never be climbed. Kailash has remained unclimbed. By collective agreement, it waits. Pilgrims walk a circuit around it, called the Kora, or the Parikrama. The route runs about 52 kilometers. Most pilgrims complete it in 3 days. Hindus and Buddhists walk clockwise. Bon practitioners walk in the opposite direction. The highest point on the circuit, the Juroma Pass, sits at 5,650 meters above sea level. Some pilgrims walk the entire Kora in full-body prostrations. They lie down on the stone. They mark a line ahead of their hands. They stand. They step to the line and lie down again. Inch by slow inch, they cross 52 kilometers of mountain ground. It takes them about 3 weeks. A single circumambulation is said to cleanse the sins of a lifetime. 108 of them are said to bring liberation. Further south in the Khumbu region of Nepal sits Tengbach Monastery. It was established in 1916 at 3,867 meters. It looks out over Everest, Lhotse, and Ama Dablam from the meeting point of 2 rivers. The building has been destroyed twice, once by an earthquake in 1934, once by a fire in 1989. Both times, the local Sherpa community rebuilt it. About 60 monks live there now, continuing practices that go back centuries. Mornings at Tengbach begin before dawn. Chanting starts in darkness. Long Tibetan horns, called dungchen, send out their deep, low notes across the valley. The sound carries far. Even in the thin air, the low frequencies travel easily. Around the monastery walls, prayer flags move in the wind. These flags aren't prayers aimed upward. They aren't trying to reach a sky god. They're prayers carried outward into the surrounding country, meant to benefit every living being the wind passes over. The wind is the messenger. The flags come in 5 colors: blue for sky and space, white for air and wind, red for fire, green for water, yellow for earth. The 5 elements arranged in a fixed order, repeating along the strings. You can stand on a ridge above a Himalayan monastery and watch the flags ripple. The colors fade with time. They fray. New ones are tied in their place. The wind keeps moving through them. There's an older idea, buried inside Tibetan Buddhism, that the Himalayas hide certain valleys from ordinary view. These are called Baal. The word means hidden valley in Tibetan. The tradition says they were blessed by Padmasambhava, an 8th century master who helped bring Buddhism to Tibet. He set them aside as refuges. Their locations were recorded on scrolls, hidden inside caves, monasteries, and rock crevices, to be found when needed. The texts describe these valleys as discoverable only in times of crisis, only when the world is under enormous pressure, only by practitioners with absolutely pure intention. The forces guarding them are said to take many forms: snowstorms, mists, sudden weather changes, snow leopards moving along the ridges. Several places around Everest are listed as Baal in old Buddhist sources: Kenbalung, Salyukhumbu, Ralwilling, Kirung, Nubri, and Rongshar. They are real geographical locations. In the tradition, they are also doorways into something larger than themselves. In the 1930s, a British writer named James Hilton drew on this tradition for his novel, Lost Horizon. He called his fictional hidden valley Shangri-La, the name passed into English. But the idea is much older than the novel. In Bhutan, India, Nepal, and parts of the High Range, the Baal tradition still shapes how certain valleys are protected. Conservation policy follows old spiritual maps. The people who live in the high Himalayas have changed, slowly, to fit the place. The Sherpas of Nepal have lived above 3,500 meters for many generations. Across centuries of altitude, their bodies have adapted in ways that show up in their genes. Most lowlanders on reaching high altitude produce more red blood cells. The extra cells carry more oxygen. They also thicken the blood and strain the heart. Sherpas don't do this. Their blood stays thin. Their hemoglobin levels are actually lower than average, yet their muscles use oxygen with unusual efficiency. Researchers call this a lean burn physiology. Sherpa muscles extract more energy from each breath of thin air than the muscles of sea-level populations. The difference shows up in two genes, called EPAS1 and EGLN1. Both genes are involved in oxygen processing. One of those genes, EPAS1, was likely inherited from the Denisovans. The Denisovans are an extinct human species. They lived in Asia tens of thousands of years ago. Interbreeding passed the gene into modern Tibetan and Sherpa populations. So Sherpas live at altitude partly because of an ancient gift from a vanished cousin species. The yak is another high-altitude specialist. People who live in the range sometimes call yaks the boats of the high plateau. A full-grown yak can weigh between 600 and 1,000 kilograms. Wild yaks live above 4,500 meters on the Tibetan Plateau, the highest range of any large mammal on Earth. Yaks give milk, they give butter, they give meat and fiber. Their dung dries and burns as fuel. They carry loads across routes no wheeled vehicle can reach. They survive on sparse alpine vegetation in places where the growing season barely exists. Without them, much of high-altitude human life would have been impossible. Yak butter tea, called po cha in Tibetan, is the daily drink of mountain life. It's rich in calories. It's warming. It uses milk from an animal that, like the people, has adapted to thin air. The villages themselves are often isolated. In winter, the high passes close. Many villages between 3,000 and 4,000 meters get cut off from the outside world for months. The passes are blocked by snow that can be meters deep. They open again in April or May, when warmer winds return. The village of Malana in the Indian state of Himachal Pradesh has used a democratic governance system for more than 1,600 years. A two-tier council, older than the democracies of ancient Greece, still meets to settle the affairs of the village. The village of Kamek, at over 4,500 meters, is sometimes called the world's highest motorable village. A road reaches it, but for half the year, the road is unusable. In the village of Ge, in the cold, dry air of Spiti Valley, there are naturally preserved mummies, about 500 years old. The cold and the dryness slowed decomposition until the bodies became something close to stone themselves. The kingdom of Mustang in northern Nepal was closed to outside travelers until 1992. It remains one of the most isolated inhabited places on Earth. In some villages, the dead are still returned to the mountain through sky burial. The body is placed on a high stone slope. The wind and the birds carry it back into the cycle of the range. The mountains feed the people. The mountains also receive them at the end. The Himalayas hold a stratified country of animals. At every altitude band, a different community lives. High among them all is the snow leopard. People who live in the range call it the ghost of the mountains. It is the top predator of the high Himalayas. It lives between 2,700 and 5,000 meters in broken rocky terrain near cliffs. It is solitary, mostly nocturnal, active near dawn and dusk. A single snow leopard can hold a home range anywhere from 12 to 500 square kilometers, depending on how much prey is available. Each leopard needs a population of at least 100 to 150 hooved animals nearby to survive in its territory. Its tail is nearly as long as its body. The tail acts as a counterweight when it leaps. It can also wrap around the leopard like a thick scarf in the cold. The wide, fur-covered paws act as natural snowshoes. They spread the leopard's weight across the snow and muffle every footstep. A snow leopard can leap up to 15 meters in a single bound. Most people who live their whole lives in the high Himalayas never see one. The gray coat blends into the gray stone. Only the movement gives it away briefly before it is gone again. The snow leopard's main prey is the barrel, sometimes called the blue sheep. The barrel isn't quite a sheep. It isn't quite a goat. It sits between them taxonomically. Its coat is gray with a faint bluish sheen, the color of storm cloud undersides. It lives between 2,200 and 5,500 meters. It survives by camouflage and by extraordinary footing on near-vertical cliffs. When threatened, it climbs to terrain so steep that almost nothing can follow. The Himalayan monal is the bright bird of these heights. In Nepali, it's called the danf or danf. It's the national bird of Nepal. The male has a metallic green crest, a shimmering blue throat, a copper-red back, purple wings, and turquoise eye patches. It's sometimes called the bird of 9 colors, for the way its plumage reflects different metallic shades depending on the angle of the light. The female, by contrast, is mottled brown, almost invisible against mountain soil. She nests where she cannot be seen. Monals use their strong beaks and legs to dig into snow and frozen ground. They go down as much as 25 centimeters, searching for tubers, roots, and insects under the cold surface. The bird has been part of Himalayan folklore for centuries. It appears in songs and stories as a sign of pride, prosperity, peace, and good fortune in the high country. The Himalayan wolf is another high-altitude specialist. It has evolved its own genetic adaptations to the low oxygen. Its blood handles oxygen more efficiently than that of lowland wolves. It is genetically distinct from every other wolf population in the world. Red pandas live in the Himalayan forest belt between 2,500 and 4,000 meters. They are small. They are quiet. Their behavior is so secretive that population counts remain rough estimates. Golden eagles soar across the alpine zone between 2,000 and 5,000 meters, hunting smaller mammals on rocky slopes. Himalayan tahr and musk deer fill the spaces in between, with pikas and other small mammals at the lower edges. Every altitude has its own residents. Every band of cold and air shapes a different set of survivors. If you've been listening for a while, take a slow breath. The mountains aren't going anywhere. Let me tell you something that often goes unsaid about the Himalayas. They are rising and eroding at the same time. Both processes happen continuously. The mountains add roughly 5 millimeters a year through tectonic uplift. They lose roughly 1 millimeter a year through erosion. The difference is small. The difference is constant. The difference has been the same, more or less, for 6 million years. That last fact is unusual. Climate has changed many times in 6 million years. Ice ages have come and gone. Monsoons have shifted, but the erosion rate has stayed steady. This suggests that tectonics, not weather, is the deeper force shaping the Himalayas. The rate of rise determines the rate of loss. It's a strange kind of balance, a slow handshake between the deep earth and the surface. The plate pushes up, wind and water grind it back down. The net result is 4 millimeters of growth each year. Across 1,000,000 years, that's 4 kilometers. Across 50 million years, that's 200 kilometers of vertical change. Most of it lost to erosion. The mountains we see today are only the surviving fraction of what has been built. At night in a high valley, sound carries strangely. It travels far and then it is gone. The air at altitude is dry. It carries fewer dust particles. It scatters less light. A small lamp inside a monastery can be visible from miles away. The mountains around it are dark stone shapes against a slightly less dark sky. A butter lamp burns inside a stone wall. The light presses softly outward, barely visible against the cold dark. Prayer flags lift and fall on faint thermal drafts. Above, the stars are very still. The cold is absolute. The silence between these things is enormous. The Dungchen, the long Tibetan horn, doesn't carry well in dense air at sea level. But up here, the low frequencies travel easily. A single deep note can be heard across an entire valley. In winter, temperatures on exposed ridges can drop to -36 degrees Celsius. The air at that temperature seems to ring with cold. Breath turns to frost the instant it leaves your mouth. Skin left bare for 2 long stops feeling. Yet inside the monastery, the rooms are warm with butter lamps and breath and centuries of stone holding the day's faint heat. The monks chant before dawn. The horns sound. The flags move. The stars keep their own slow rotation overhead. Let me return to where we began. Somewhere near the summit of Everest, locked inside gray limestone, are the shells of creatures that once drifted in a warm prehistoric sea. Not as metaphor, not as poetry, literally. The highest point on Earth is made of ancient ocean floor. The shell is older than the mountain, much older. By the time the Himalayas began to rise, the small creature that made the shell had been dead for nearly 400 million years. Its body had become sediment. Its sediment had become stone. Its stone was carried slowly from the southern hemisphere to the top of the world. If you reach the summit, you stand on something that used to be the bottom of a sea. The collision that lifted the seafloor into the sky began before there were humans. It began before there were primates. It began when dinosaurs still walked the earth. It hasn't ended. The Indian plate is still moving north. The mountains are still rising. The seafloor is still climbing. In the time it takes you to fall asleep tonight, the Himalayas will rise about 1,000th of a millimeter. Imperceptible, but real. Somewhere on a high ridge, prayer flags move in a cold wind. Inside a stone monastery, a butter lamp burns. A snow leopard moves along a slope, gone before it can be seen. A glacier contracts in the cold and releases a single low note into the dark. The mountains aren't finished. The ocean isn't entirely gone. The world is still becoming itself slowly while we sleep.